Hello students and friends, welcome to the Thrust of Curiosity. In this video, we are going to see another simulations on spring mass. So if you type spring mass oscillator simulation, you will get these three different, there will be some other also, but we will focus on these three. And already we have seen on PhET simulation, so I will go on O physics. So let's see what is the simulation here. So it is supported by GeoGebra. Okay, now let's see if we hit run. This is going to oscillate. Here is x equal to 0 and these are the amplitudes. So it is almost 3 units. Okay, they are saying there is 3 meters, and now you can see, you can pause this, and at that particular instant you can see position, velocity, kinetic energy, potential energy, acceleration. Okay, animation speed you can change, you can see the time graphs. Okay, let me uh, again run. So you can see here how the position is going to change. So this is total mechanical energy which is constant, it is not going to change. Now what we can do, we can change here the mass, and I have reduced the mass, and let's hit the run. Now you can see the graphs are plotting, and you can see much lower energy instead of than the earlier system. Suppose I increase the spring constant, you can see the energy is shifted. If I hit run, you can see the graphs are coming here. So this is very good simulation, you can see. Now let's go back and look at the another simulation by my physics lab. Now you can see here it is single spring, and you can see here energy, you can see here timer, and there are different things here. We can see the graph. Okay, you can see this is a damping. Amplitude is continuously decreasing. We might reset here. And how to start this? Okay, here started, and now we can see the graph here. Okay, there is a pointer here, and how the amplitude is going to change over the time. Okay, you can see here. Here in this graph, this is x and this is y position, and here you can see the timer. And this is nothing but the total energy is going to decrease, that is also shown here, and after some time it will reach to 0. Okay, this is time graph, and this is multi. Okay, both graphs can be seen here. Okay, if I reset this and run and hit on multi, you can see here. So as the oscillation is progressing, you can see how the position is changed from here, and I guess these are speed and accelerations, or position and velocity. Okay, this looks nice. If I go to this myphysicslab.com, we will see another simulations which are related to spring mass. You can see here double spring. Let's go with double spring. Just now we have seen the single spring. Okay, Now you can see here there are two masses and they are attached with the two springs, and these two are boundaries we can say. And let me stop this simulation and let me increase one mass, and then let's start. Okay, what we can have a graph here. Wow, amazing. So okay, let me just reset this. This to 1, and now let's start and again see the graph. Again it is similar kind of behavior is there, and this is because of two springs and mass system. Now let's have different masses. Now we are not able to understand what is going to happen because this complex behavior. Okay, so this spring is going to stretch and compress, and when it comes here this spring is going to also stretch or compress, and therefore instead of single spring we can see here there are more number of oscillations we might observe here, uh, because the spring stiffness is less. But if we increase, I will reset this first and then start this. Okay, you can see this, and if we add third spring, now here you can see both systems are in the bound state. Here, before adding third spring, there is a freeness in this second mass. Okay, and if I add third spring, there will be more oscillations. You can see here it is oscillating more. So does this mean instead of free mass spring mass system, I mean mass is spring from one end, there will be less oscillation if the masses are not free from both ends, then the oscillation is more. And in this also I can see this mass is oscillating, okay, because the mass is less here. Okay, okay, let me make them same. Okay, they are almost same, and now you can see both are having the same kind of oscillation, and there is no damping, therefore it is going on forever. But if I add kind of damping, after some time they are going to stop. Here we can see the rest state. If I change the mass, first mass, you can see now because the mass of this is less, it is oscillating more. Okay, let me try to increase this mass. Now you can see this is oscillating more. Okay, let me reset and now start oscillating. Now they are not much showing not much difference. Okay, but this seems interesting. We are not getting what is this graph showing, and because it is plotting on the same part, we are unable to distinguish between earlier plots. And this is time graph. So how x and y is going to change with time. So let's again go to the this original thing, and here we have 2D spring and 2D double 2D spring. So we will check them also. So let's see 2D spring. So you can see this can oscillate in vertical as well as horizontal. So therefore it is 2D spring. So here a single mass is attached, and you can see the graph here. You can see how that is going to change, and it is showing some beautiful pattern. Now here also we can have some, we can change the spring length. We can do different. Okay, let me reset first. And now, okay, now it is oscillating more randomly. Let me check the graph. Okay, it is the amplitude is going to increase. You can see here. And now let me reset this and decrease this stiffness, and then run the simulation. Now because this is less, k is less, the extension is very much bigger. You can see here, this was the first when the length was some length we have picked, and then we decreased the length, then we got this much, and now we change the k value. Now we are getting this much amplitude. So here also we can compare things, and it is visually appealing because we can see the graphs, very beautiful graphs coming here. These are some patterns we are getting. Then we will go to the next from here itself, and that is double 2D spring. You can see. Now this looks like a chaotic oscillations. Total energy is about 11 joules. Now this also you can check from here how the energy is going to change. If I increase the mass, you can see now total energy is increased. If I reset this and run, you can see the graph. I'm not able to reset this graph. Okay, yeah, here is a clear graph option. Yes, yes. So, okay, let me stop this. Reset this. Clear the graph. Okay, we have here option for color also. Okay, let's select, let's select red. Okay, here we have drop width, and okay, let it keep one, and dotted also we can have. Let's check first this one. Now this is becoming red. Okay, now let me stop again and change the color, say green. And now we'll make some change in stiffness. We are keeping the length constant, but stiffness we have increased. And now let's see. Now you can compare this. You can compare that this amplitude is more if the stiffness is more. But anyway, this looks like something chaotic happening is there, but I'm sure there will be some kind of pattern will occur after some time. Now, though we are saying this is a 2D, this might go to 3D here, but we are not able to understand 2D, so I don't think we can able to understand a three dimensional. But anyway, this looks amazing. So very nice simulation. We can check here. We can check here other simulations also, like our PhET simulation. This is myphysicslab.com. So in next video we will discuss some more kind of things. Thank you for watching. Like, share and subscribe.